Hi everyone, in this video let's try to understand the classification of data structures that we have. So based on the way whatever the values we have in that respective data structure, how we are arranging those values, data structures are basically divided into two types. One is linear data structure and the other is non-linear data structure. In the case of linear data structure, right, what exactly is a linear data structure? In the case of linear data structures, all the values that we have in that respective data structure, right, they are basically arranged in a sequential manner, one after another. Okay, remember that all the values are arranged sequentially one after another. That's the reason why we call it as a linear data structure. Since all the values are arranged linearly, we will be able to run a simple for loop and we will be able to access each and every value we have in that respective data structure. Okay, so that is linear data structure. Then what exactly is a non-linear data structure? As the name indicates, in any data structure, if the values are not arranged linearly sequentially one after another, then we call that specific data structure as non-linear data structure. If the values are not arranged linearly, then how the values are arranged, right? For example, let's just try to take the case of trees. In the case of trees, we basically each and every value we have can contain further child nodes, and all these child nodes, if you look, right, they basically look level by level arrangement. Okay, this is the example of tree data structure. When you take the graph data structure, right, graph data structure can connect with any node that we have and with any other node that we have inside the graph as well. When it comes to graph, the values are not arranged in a level by level fashion, and any value basically can connect with any other value that we have inside the graph. Basically, one thing that you have to understand here is values are not arranged sequentially. In the case of trees, they are arranged level by level manner, and in the case of graph, there is nothing that a specific principle is followed. Any value can basically connect with any other value that we have inside that respective graph implementation. Okay, since these values are connecting randomly, we will not be able to do a simple iteration by using a simple for loop. We basically need a some other data structure help to read each and every value we have in that respective data structure. That is something that you have to remember. Okay, so all the linear data structures, right, in which all the values are arranged linearly sequentially, they are basically further divided into linked list, set, stacks and queues. Okay, if all the values inside these data structures are basically arranged linearly, then what exactly is the difference between these data structures, right? When it comes to linked list, it doesn't have any restrictions on what kind of data it will store and how many number of times a value can appear, whether the null and none value insertion is possible or not. There is no restriction at all in the case of singly linked list. By using those properties, we will try to create the values of linked list that we want inside it. Okay, when it comes to set, right, set basically allows all the properties of linked list with a removal of having a duplicate values in it. Just remember that whenever we are speaking about the set data structure, there will not be any duplicates allowed inside the set data structure. And stacks and queues are also all the properties whatever we have in the linked list will have similar properties, but it's just that in the future, maybe during some implementation, we may want to use some data structure in which the order of inserting and removing the values is of utmost priority, and we basically want to prefer a particular order of inserting and removing the values from that respective data structure. So stacks and queues is nothing but that data structure in which the way we are going to insert the values and the way we are going to remove the values basically happens at a particular end. Okay, at this point of time, don't worry about the properties that I'm mentioning. I'm just trying to give the simple overview of the data structure classification. In the future videos, as we go ahead and implement each and every data structure, right, we will be understanding each and every data structure as an abstract data structure first of all, and after that, according to the abstraction that we are trying to understand, we will go ahead and we will implement that respective data structure. Here just try to understand how they are classified. In the case of non-linear data structures, basically they are divided into trees and graphs. Especially in our course, we will be talking about the binary trees, and we will also be implementing the binary search trees as well. And whatever the graphs that we have, right, these graphs are further divided into directed graphs and non-directed graphs, and each and every directed and non-directed graph also further divided based on the weights associated to each and every connection that is available between the two nodes that are there in the graph as well. Like I mentioned, I'm just trying to give the brief overview of the data structure classification at this point of time. If you are not aware of the terminologies that I'm mentioning, don't worry, we will be doing thorough investigation of these properties when we discuss the respective data structure. Anyway, that is the data structure classification. Basically, linear data structures and non-linear data structures. Some of the examples of linear data structure are linked list, stacks, queues, and set data structure. And some of the examples of non-linear data structure are trees and graphs. Okay, so that's all is the data structure classification. Thanks for watching. I'll see you in the next one.